Good morning and welcome to Developer X AI, a virtual event that brings together the brightest minds in software development in Finland. I'm Vibha Deshpande and I'm a Fast Track Partner Manager at Microsoft.
And I am Inari Bergius, an Azure Specialist at Microsoft. We are thrilled to be here with you today. This event offers a unique opportunity to gain expertise on AI technologies, specifically on GitHub Copilot and Azure AI services. You will hear from expert practitioners and innovators who are using AI to transform the way they code, create, and collaborate. This event is about connecting the dots between theory and practice. It's for developers who aspire to be at the forefront of the innovation by learning from real-world applications and network with peers driven by the same passion.
If you're looking to transform the way you think about development with AI, you're at the right place. We have a packed agenda for you with inspiring keynotes, insightful sessions, and interactive Q&A. You can also join the conversation on social media by using the hashtag DeveloperXAI. Before we begin, I'd like to thank our speakers for making this event possible, and a big thanks to our audience, every one of you on the line. A special thanks to a number of you who've probably been staying up late at night catching up with the Microsoft build sessions. Without your support, we wouldn't be able to bring to you this amazing content and experience.
Yeah. Now, without further ado, let's kick off the event with our opening keynote. Please welcome Jouni Heikniemi, Azure Regional Director, CEO of Devisiona, and a good guy in general, who will share his vision and insights on how AI is changing the game for software development. Let's go, Jouni.
I have been in IT for like 30 years. I was here when World Wide Web took its place. I saw the dot-com boom. I witnessed Apple launch its iPhone, making mobile services with a good user interface possible. And I still remember how public cloud was launched, first with AWS, then with Azure. With all that said, I think the last year may still have been the most exciting of my professional life. Welcome to Developer X AI, and good morning to you, everybody. I'm going to kick this session off by talking a bit about the evolution of the last year and where we're going to be headed. Because the arc, the last 13 months, since we last had the Developer X AI event, has been an awesome trip. It has been a year full of opportunities, full of threats, full of disappointments, full of very, very interesting sessions on different conferences, full of interesting product launches, and full of business uncertainty, full of learning. Last year, we thought we were at the top of it. We thought we knew everything about AI. We thought we were going into something new, and now we knew what we were going to do. And it has turned out we knew nothing. Let me start with a few highlights from last year's event, or you might also say lowlights, because this is kind of in retrospect. It only shows you how immature we were a year ago. For example, we were talking about GitHub Copilot, a great topic. But it was a very immature, just a code completion tool. Just getting adopted, just individual licenses, no chat features, nothing. We were just dreaming about things like that. Azure OpenAI service, we're also talking about that one. A new preview level service, still maybe feared a bit. What is this? This is undeterministic. And if you look at the model choice available, we were talking about GPT-3. Okay, we actually had 3.5, but we had no GPT-4. Azure OpenAI service was very different from what it is right now. Vector databases, barely even mentioned, because things like grounding, RAG patterns, they were not on the top of mind of everybody like they are now. And finally, and perhaps the most importantly, the trust question. Because here in this picture, you can see Antti giving the advice that you should not give AI any information you would not be ready to leave out as a printout in your lunch restaurant table. Now think about what it means. It means a fundamental distrust towards AI and large language models. But the background for that recommendation was that right before he went on stage, we were discussing in the green room, can we trust OpenAI when they just previous night had added to ChatGPT a switch, do not use my data for training? Can we trust OpenAI? Now, there's been a tide of change in this past year. First of all, GitHub Copilot is now an industry standard, no questions asked. It's available everywhere on multiple IDEs, and it has lots of features. There's so much going on, and there are going to be so many sessions about that, so I'm not talking about any more of it. Azure AI, used by 50,000 organizations, as published by Microsoft and Build yesterday. GPT-4. Not only do we have that, we're now looking for GPT-4o, but in between we also saw GPT-4 Turbo, we saw GPT-4v, we have seen several iterations of GPT-3.5. So a lot going on with the base models as well. Vector database, barely mentioned last year because we didn't even know we needed them a year ago. But now, they're available in multiple foundational Azure services, including Azure AI Search, but also Azure Cosmos DB, Azure Data Explorer, and even Azure SQL Database. So the database fundamentals, the data estate fundamentals for every enterprise are coming up to meet the need of AI. And then, the trust in data security and IPR protection. There is still all the reason to think about where you're deploying all your data, but overall, I think we are past the point where we didn't trust the models. Because right now, we think language models are just another example of our overall IT estate. We use them just as we use any other cloud service, like Microsoft 365, or Azure Blob Storage, or anything. So yes, the models are secure, and we can trust them. This is just the matter we talked about in Developer X AI. But then there are other evolutions going on. Copilot for Microsoft 365. Last year, it was an annoying marketing presentation. It was an animation that looked too good to be true. And after that, after we waited a lot, we had a period of disappointment because it was not available to us. It was only available to maybe some enterprise customers with like 300 seats minimum. Then we had another wave of disappointment because when we had that, we could not prompt using Finnish, or it did not create Finnish content, or it did not summarize Finnish emails. Now, finally, 1 month ago, we have this Finnish-speaking Copilot. And that's going to be very relevant because it's also a software development service, not just a service for modern workers. But as you can see, here in this 1 year span, we saw 2 waves of disappointment and then finally success. But all this in 1 year, and we're talking about a fundamentally new category of IT helpers. Moving on more technical topics, retrieval augmented generation, RAG. This was not a thing a year ago. We understood that we wanted language models, but we didn't know what to do with them. We were first so excited with just being able to chat with them in a secure fashion, using them for translation, summarization, features that do not require fundamentally our own data. But what RAG is, it's the art of feeding the language model the information you want it to use. So essentially, you are replacing the model's basic training with your own data and relying that you can provide better data. And it contains all these technical steps, a detailed conversation, just a journey we're starting to learn, really. In terms of Google Trends, RAG as a search keyword in a technical sense, it just started spiking in the Q4 of last year. So all of this is like half a year old. And if somebody says they're a RAG expert, well, they can be an expert, but they practically have maybe maximum 1 year of experience. So it's a very new field, yet all of our AI applications really are fundamentally based on this RAG thing. Amazing evolution. We have created a new tool set, a new need, right from thin air. Then I want to highlight semantic kernel, a very unused and poorly understood feature, or I might say addition to your application development. What semantic kernel is, it's an open source library built by Microsoft. It is available in 3 languages. It's available in .NET, in Java, and Python. And for all these languages, semantic kernel enables your applications and LLMs and their plugins to interact in a natural fashion. So what semantic kernel enables you to do is, for example, you can have a prompt box in your application, and you can use it to create complex commanding scenarios. For example, you can have a prompt user can type something like, create me a 3D model based on this data I have in this application. And what semantic kernel does, it is able to split that request into multiple parts and then orchestrate the execution of different plugins that can then alter your program state or retrieve additional information from other sources. So semantic kernel is what you can use if you want to build an actually intelligent application that is able to converse with your user, just like Microsoft 365 Copilot does. A very understood feature or library, and I would heartily recommend getting introduced to it. So essentially, we have created a new application category. What this means is we are now building these chats We are building systems that are able to converse with the user in a natural language. And often that conversation goes wrong. Like in this example, GPT gets my bio wrong. I'm not a professor in information science as much as I would like to be. I'm not that. So we are still dealing with the quality issues of these applications we have created. But what's next? Because we are looking into the future, and I know now I am better than last year. I know we're not at the final stage of AI because so much is going on. Let me give you some guesses on what's going to happen in the next few years. We're talking about an explosion of base models because we were so happy with GPT 3.5 being able to generate poems in Finnish that we didn't even look into the future. Then we realized GPT-4 is going to be much better in reasoning. And now we have seen the demos that prove that GPT-4o is vastly more capable of producing imagery, understanding voice, being able to converse in real time. This all has created another dilemma for us as developers, because now we need to think about model choice. Are we going to use the latest and greatest, perhaps the most expensive model? Or are we going to fall back for some scenarios on known, older models, which may be cheaper, faster, but not as capable? So this model choice dilemma is just getting to open up in our eyes. But that's not just GPTs. We also have lots of other options. Some of them are really competing models. Some of them are just complementary models. We might well build a solution that uses Phi-3 for processing something and then uses GPT-4 for something else. And if you think about a large-scale solution like Microsoft 365 Copilot, they have to use several models because there's just simply no cost-effective way to run everything on a single model. If you look at Hugging Face screen cap there are almost 700,000 models available for you just to download. Some of them are image models, some of them are text models, but there is so much going on in the model space, and just understanding which model to pick for each scenario, that's going to be an art in itself for the future years. What this also enables is a hybrid approach to hosting those language models, because our premier approach has all the time been these large language models, these headliner models, GPT's latest version running on the cloud. And there's absolutely nothing wrong with that, except that you cannot use that for everything. Now, we're starting to see that being complemented by small language models, which are significantly smaller in size, and they can be hosted locally. So you can have that small language model running on your phone. You can have it running on your Copilot Plus PC with its built-in NPU processor. Or you can have a hybrid configuration where that small language model gets hosted in the cloud. And why this is relevant? Because as an application developer, you need to look at what's the right solution for each of these problems. You want to use large language models for scenarios where you need the most language support, you need the most comprehensive background information, and you need the most intelligence for orchestration, the best reasoning capabilities. But you don't need that for everything. Your application may do some reasoning, but then you will find that the most of the LLM calls it does are actually just doing very simple things such as summarization. And you may know that, for example, Microsoft Phi-3 does that summarization quite well. So you can be cheaper, faster, and most importantly, you can do some processing near the data. For example, think about a scenario where you have like 7 cameras doing CCTV footage for a single industrial building. You want to analyze that using these models. I don't think it makes sense to say language models because they're image models as well. Anyway, you can do something like use Phi-3 to analyze those images locally and understand these segments of the video are worth further analysis. So you will then just in those segments of the video up to the cloud to analyze using a larger model. And this is a complicated thing where we have to understand what each model can do and what we're going to do with those. And also, we're going to move from just text to multimodality. So we're no longer happy with just the poems and just being able to have tokenized text understood and then responded to. No, we're looking into having vision as well. So, for example, I can pick up my McDonald's Coca-Cola glass of a vintage like 5 years ago. I can ask ChatGPT, where can I get one of these glasses? And GPT-4o and Bing is going to be able to analyze the image and actually understand it's a vintage glass nowhere available as a new thing, but it can give me eBay links on try finding this. So these scenarios are already possible, but they are just not integrated in our own applications. If you look at GPT-4o demos from like 2 weeks ago, you maybe saw this one. There are 2 GPT-4os singing to one another. Unpredictable advances in voice understanding, in real-time conversation have made the whole field of AI wholly different because people want to use AI. They want to have natural language as a user interface, but they don't want to type everything. So they will want to use their cameras for data input. They will want to use their voice for command input. And now we, as application developers, need to provide the user experience for that. The models will do the heavy lifting. We have to provide a lot of context for the models to actually do their work right. And that's going to be a significant challenge for us as well. And finally, I want to talk a bit about the development stack in terms of architecture and what's happening for us as developers. Our traditional state, where we are right now, is something like this. We have a managed cloud that is a very well-established fundamental here, something like well-managed Azure built on cloud on adoption frameworks, and that is cool. Then we have these applications built on top of them. For example, an ERP. It will contain a data layer. It will have some kind of security measures, including authentication, data access management. Then it will have business logic and user experience layers. What's happening next, and what's already happened in some of the enterprises, we are seeing a data and integration platform renaissance. So we are seeing that there is going to be a single platform that contains all of the enterprise data estate, has the integration capabilities to bring the data to every application. We're going to have the APIs, the service buses, to bring data real-time into eventing fashion to every application that needs it. Because by God, we'll need that. There will be applications. So we're looking at an explosion in the number of apps to be built. We're going to have product information applications. We're going to have CRMs to manage our customers. We're going to have line of business applications to manage everything from the company cottages, reservations, whatever. And where those apps are going to come from, because we don't have all the developers to build them in terms of pro code, and that's not going to be financially feasible either. So we're going to see customer SaaS solutions. There are going to be so many SaaS apps brought into the enterprise, and they still need to be within the same data fold. We're going to see Power Platform used heavily to build low-code applications. And also we're going to see brave souls building their own apps, because some of those people are actually going to use something like SharePoint lists to set up a data store, and then they're going to use Microsoft Forms to set up a user interface, and then they're going to use Power Automate to glue all those together. So essentially what they're doing is they are creating applications. They're just not creating applications in the sense we think of them as apps, as developers. This is an enormous challenge, because this already requires us to have all of the enterprise data opened up to the application conversation, to the application evolution we're seeing. But then we enter AI into the equation. We drop in Copilots. Microsoft is making every modern worker expect Copilot as a user interface. They want that text box where they can type in a prompt. Well, your applications are going to include those text boxes. You're going to be using something like semantic kernel to build those boxes where you can enter some kind of natural language expectation or request for information. And then the user expects your app to comply. The problem, or I must say challenge, or opportunity here, is that you're going to have to participate in this ecosystem even if you decide not to build a Copilot yourself. Even if you decide not to use semantic kernel inside your application, you're going to have to participate in the ecosystem, because there's going to be a single button that will change the equation again. New Windows PCs are going to have this Copilot key. When you hit that Copilot key, what's going to happen is that Microsoft is going to open up a Windows Copilot. And in all the demos, there's going to be a Hawaii vacation planned. But in reality, business customers are going to type in some business prompts for that. Create me an expense report for my last week's trip to Stockholm, for example. That contains several complex expectations. Your expense reporting application must participate in this ecosystem. It must be aware of Copilots being able to send some requests to it. It must have the context. It must know who the user is when they're asking. And if they refer to their last week's trip to Stockholm, what do they mean? What information do I already have from it? Can I use the user's calendar, for example? Then that application is going to render some kind of user interface in this experience. It may be an adaptive card, or it may be a link to the application itself. But anyway, there's a significant sea change here, because we're not going to have people primarily just choosing the application they want to use. They're going to type in or say out loud the user scenario they want to engage in. And that's going to be a huge change. Then, when we're satisfied with this and when we're done building all this, then we have to talk about agents. Because agents are going to mean that not only do we have these copilots working on behalf of the user, but we also have agents working independently in the background, because some user has given them some powers, some tasks, and some time to complete the task. So your app has to be able to talk, not just to the user in natural language, but also to other LLM-powered agents. And that's going to be a significant change. But if you look at build for this week, you will already see that there are several sessions where we're moving forward with the agent technology. We still need to find out the integration and user interface patterns for this one, because it's going to be complex. With all that said, it's easy to think I'm late to the party. You're not late to the party. As you have seen, this last year has been a massive change we could not predict a year ago. Now we know there's going to be a lot of changes also for the next year. I covered some of them, and I'm fairly confident they're going to happen. But also I'm certain that there are going to be others that I did not realize were going to happen. So you will be here learning new things, even if you start now. Every moment, every day is a new beginning, said by some wise man over somewhere. And we are just getting started in terms of developers and AI. I'm Jouni Heikkinen from Devisiona. Thank you very much for joining me, and enjoy the rest of Developer X AI.
Thank you, Jouni, for that inspiring keynote. Thank you for instilling hope, showing us the opportunity. I'm sure you're all pumped up and excited. I'm sure you all learned a lot from his perspective and experience. GitHub Copilot is the world's most popular developer AI tool, bringing new levels of productivity to teams and opening up to allow developers to build agents and skills to further extend the AI assistance. Next up, we have Jonas Hellin, Cloud Solution Engineer at GitHub, who will tell us more about GitHub Copilot, your AI-powered coding assistant that helps you write better code faster. Jonas, over to you.
Okay, welcome. So this session is called GitHub Copilot, What's New and What's Next. So we will be looking at some of the latest advancements we have just released in GitHub Copilot, and we will also be looking at what's coming next and things we are just starting to talk about and just are getting ready to release. So the overall theme of the things that I'll be showing is related to, we started with auto-completion, right? And we know that most developers will only spend maybe 25% of their time writing code. Rest of the time will be doing other tasks as a developer. And the overall theme of the things that I'll be talking about is adding AI support for those other tasks you do as a developer. So I'll be talking about three different themes. First one is extracting information from existing repositories you have in your organization. A lot of enterprises have tons of old repositories, tons of old documentation, and it's hard to kind of collect the data out of all of that information or all those repositories. So that is the first theme we'll be looking at. So let's jump into the code here. So in this organization, we have a number of repositories, and some of them are used to store information, like wikis. So as a development team, you'll have a lot of choices where to store your documentation. You can store it in SharePoint, you can have it in Confluence. If you're using Azure DevOps, you might have a wiki. If you use GitHub, there's a high chance that you are using repositories to store information. So we have a number of repositories here. One of them is called this one, Employee Handbook. So this is for my organization. This is the information we want to collect, and we want all our employees to know, like what is our policies, and so on. And that is great. Of course, there's a lot of work to keep up with this and read this. And what I've done is I've turned this repository into a knowledge base. So this is one of the functionalities you have access to in Copilot Enterprise. It's called Create a Knowledge Base. And basically, I created a knowledge base called Employee Handbook, mapping to this repository. So what I can do then, so you can see here, I've started a Copilot chat in github.com. And I've selected that I want to chat with this knowledge base, this Employee Handbook. And I can ask things here like, what would I have to do if I wanted to work from home next week? And instead of me going into the repository, trying to find the right information and reading it myself, I basically can ask questions towards this, call it wiki. And here I get a lot of good suggestions on what I need to do. And another thing to note here as well is that we get a lot of information, and we also get references, right? So I can jump in and take a look at where Copilot found this information. So Copilot will pick up information from a lot of different locations in this wiki. I can ask things like, do we have referral bonuses? GitHub Copilot will again search the knowledge base, the wiki, and say, yes, we do. So that is one example, having an employee handbook as a knowledge base. I'll switch to this one. This is maybe a more realistic example. So we have all our coding standards documented in a wiki called JavaScript Coding Standards. And I can ask things like, why should I avoid using var as my references? And you can really think of this as Copilot, in this instance, being a really native, really good colleague that has a lot of knowledge on how to write JavaScript, but has also read our wiki on how we in my company should be using JavaScript. So Copilot will combine this information. If I continue and go deeper and ask things that are not in the wiki and not documented in this information here, Copilot will answer with the knowledge he's already known. Okay, so that's knowledge bases. And basically we've done a very similar thing with code bases, right? It's great to be able to extract all this information of all these wikis and readmes and documentation you might have lying around. But an even more common scenario is that you have a repository that you need to get an understanding of. So this is a repository. This is an application that me and a colleague are just starting to get ready to work on. It's a web app, so we're hoping to go big with this one. This actually has a code space, so I opened up a code space here, and the code space is running over here. So this is so for me, when I want to understand this repository, I will have to go in and read a lot of code, right? So I see there's a backend, there's a front end. I actually have already started a bug session for this one, so I can go in and look at the user interface as well. So this is the start of our weather app. It has a weather forecast. It has another page. You can see date, temperatures in Celsius and Fahrenheit, and summary. I also have this precipitation tab. And that looks to be throwing an exception. That's kind of sad, but okay. So this is what I know. So now I need to get a better understanding of how is this application actually built up, and how do I do that? Of course, I can go into the code. I can read a lot of code. I can set breakpoints, step through code. But what I can also do, if I have access to Copilot Enterprise, is ask questions on this repository. So I can ask things like, let's see if I can get this going here. How is this solution built up? What are the components, the relationships, and frameworks being used? So this is a great way for me to get deeper information. So Copilot will look at the code and basically parse the information here. So it tells me the framework is Blazor. I haven't been using that a lot. C#. Okay, so I get a decent understanding. Another thing that I'm not really clear on is these temperatures here. They seem to be varying a lot. I'm not sure if they are actually a real temperature or if this is just something that is made up. So let me ask that as well. So the temperatures that are shown, are they just random values, or where do they come from? So of course, if I had a colleague that had 100% knowledge of this repository, I would probably ask him. But now Copilot is there for me, has synthesized this code base, and knows a lot about it. So I can use Copilot instead for my questions. So it seems like the temperatures we're seeing, they are randomly generated. Okay, good to know. I think I have a decent understanding of this repository now. So that was the first theme, like being able to extract information from all the repositories and everything you already have as an enterprise. The second theme is related to the models and extending the models. So the models we have access to from OpenAI, they are truly amazing. I think you all agree, and I think you all have played with them. So let me just show the capabilities of these models. So I'm asking, oh, sorry, I'm going to do this. So I'm asking here, can you please help me create an HTML page that is a biography of Rick Ashley? And this is not because I love Rick Ashley. This is just to show like how much knowledge is actually in these models, right? So let's insert this into a new file. So actually, let me give some more information here. Rick Ashley was born. And let's see if Copilot knows when Rick Ashley was born. It does. Great, excellent. This is a coding support, right? But still, it has so much knowledge in here, and we're using only a fraction of it. So the lyrics of a song "Never Gonna Give You Up" goes like this. So the model knows the lyrics to "Never Gonna Give You Up." And I can even, let's say if I want to translate it to Finnish, can we get this song text in Finnish instead? Yeah, for sure. The model has so much knowledge, right? So it's quite amazing, but there are limitations to the models, and that's the next theme that I want to discuss. And so one of the things that we will for sure have a limitation with these models is like the cutoff date for training. So if I ask something like, when was Java 22 released? This Java 22 was released after OpenAI was done with the training. So this model doesn't know anything about Java 22. So it's great if we can extend the model, right? And one of the things we want to extend it is with new information that has gone live after OpenAI was done training the model. So let's take a look at on how we can do that. So let me start a new chat here, and let me actually ask the same question over here. And again, we are looking at what's coming next. Ideally, I would get the same results, independently of where I was using chat. But currently, the information, and the thing is with these models, is that once in a while, you will get different results. So I'm pretty sure that it will know. If not, I will try to rephrase the question. Okay. What was included in Java 22? Yes, yeah, this is the issue with generative AI, right? You can do a demo in the morning. Okay, this is kind of sad. The thing is that I wanted to show is that what it actually does is it's using Bing, right? And it's going out in Bing, and it's basically extending its own knowledge. And you can see that it was using a Bing search. And for some reason, just right now when I'm doing the demo, Bing can't return any replies for Java 22. But this is a way for us to extend the model, right? That's one example of how we can extend the model. We can also extend the model with other information. So actually, I have a couple of issues here. And one of the issues I have is this, what we saw. We get an exception when we throw this, when we try to view the rainfall tab. So I'm going to ask GitHub Copilot, can you understand what the problem can be with issue number 3? And I'm typing really fast, but once in a while I make mistakes when I type this fast. So GitHub Copilot, again, of course it can't have this information in its model itself, right? So in this instance, it needs to go out into GitHub, read the issue, and try to understand. Okay, so it's found that it's related to an exception being thrown on the precipitation tab. That's what we know so far. I'm going to ask also this one, can you see any reason why this would be thrown by the front end? So again, of course, I can do my own debugging, but I'm going to use Copilot and see if here with this knowledge, look at the code. Okay, this is kind of typical. Just when you're doing a demo, GitHub Copilot has full knowledge of this repository. But of course, when I'm doing a live demo, it will not show it. Is there a exception? Exception thrown by the front end? And usually what I'm expecting is GitHub Copilot to look in. Oh, and again, he says, no, sorry, I will not be able to do that. The thing is that actually, let me do this. Let me start a new chat here and see if I'm more lucky this time around. Great. We're fine in that one. We want to see, like, can you find why the front end would be throwing this exception? Let's see if Copilot shapes up now and we're able to look at my code and see. Yeah, and this time it worked, right? And this is kind of typical when working with this generative AI. It works 90% of the cases, once in a while not. Okay, and we can see that the reason is that we actually have a throw not implemented exception in the code. So it seems like we are not fully done with the code here. So I'm going to switch over to Visual Studio. I'm going to continue here, and I'm going to be asking. So looking at this file here, I can see the exception again, right? So I basically can select all of this, and I can type, when will this exception be thrown? And we can see that it's being thrown in this initialize. So Copilot explained to me that I will get this exception every time I reach this page. So that's not ideal, but still, if this has not been released to production, then there's really no big deal. So let me actually ask the production system. So production system, this is my connection into the production system, and I can ask questions towards this one as well. So let me ask this one here. Do we have any exceptions or like this in our production system? So in this instance, again, Copilot, the model itself, doesn't have all of the information, but it will reach out into Azure in the production system and see that we have been getting some of these exceptions, and it's been starting May 15th. It will also tell me that I did a release on May 15th, this release here. And it included like getting started on the rain page. So it seems like we should have had better DevOps policies, and we should have probably checked this before going out to release. But it seems like we have a live issue in production. So that's not great. So still, that was theme number 2, being able to extend this super capable model with live information and information from other sources like Bing. Okay, so I'm in a bit of a problem here, right? So I have this live site, and it hasn't implemented this thing with precipitation tab. And of course, I can do a rollback, but I don't want to do that. I'm thinking maybe I'll just try to implement this tab here during this demo here. So we have a specification. We have an issue here, basically detailing what we want to get done. So it says here, like, we want a new tab on the left-hand side. The UI for the precipitation tab should be showing millimeters and inches of rain. This should be random data. We need to extend the backend, and the architecture should be similar to what we do with temperatures. So I never worked with Blazor before. This is going to be tough to. We have 3.5 minutes left in my demo here. Let's see if we can get this done. And I would not for sure. This would take me hours to do myself. Let me see if I can get Copilot's help in getting this done. So what I'm doing here is I'm opening up a Copilot workspace, a location where I can work together with Copilot and try to figure out how I can implement this. So we have a specification. We have listed what we want to do. First thing that Copilot will do, it will list all the things. It will look at the current state. So it says, let me zoom in again here. It says the application already have a tab like this. And it's showing this tab, but actually when we try to view it, we get an exception. We don't have a backend. We have a class for containing the data, but it's not implemented. So the proposition here from Copilot is that we will add a new tab, we will implement it in the navigation, we will implement the user interface, we will implement a backend, and we will implement like a data object to contain this as well. So this is good, but I also want to have some update the README. So I'm going to add this as well. Update the readme.md to mention the new functionality. That I think is what we want to do. Okay, great. So that is on a high level what we want to do. And let's get Copilot to build a plan. How do we actually do this? So GitHub Copilot will go in, analyze, look at the files we have, and basically write a specification per file we need to change. So this is the backend, and this is basically the backend endpoint. So we're adding a backend endpoint, participation forecast, and we're going to have random values, we're going to have millimeters, inches summary, we're going to implement the data class, we're going to implement the user interface, we're going to be able to pass this backend call away, and we're going to update the README. Looks good to me. So I'm going to ask Copilot, can you please help me now implement all this functionality? And the one thing I'm a bit worried about is this one here. This is one of the things we saw here was that we had these summaries, and I don't think we talk about that in a good way. Like, how should we actually be generating these summaries? So let's see what Copilot comes up with. This looks actually pretty good. So you can see we have a similar style as we had before. We're getting these summaries. We are getting random values for let me go back here. Where is my tab? Do I need to do it again? I'm going to generate the plan. Sorry, I lost. Oh, here we are. Great, it was already there. Implement selected files. Okay, and we're back, right? The thing is that the one thing that we're missing here. Yeah, let's leave it at this. We're running out of time. But you can see where we have basically implemented everything we wanted to get done, right? So this looks pretty good. What I can do now is I can generate a pull request. So let's do this one. Let's do a branch name called Finland here. And GitHub Copilot. Ideally, I would be able to now start this, right, and debug this code. But instead, what I'm going to do is I'm going to open a pull request, and I'm going to check this branch in. And when I have this branch checked in, I will be able to get to this branch from here. So let's see, do we have a new branch ready to go? We called it Finland. FI, do we have it? No. Do we need to do a git pull? Still no Finland. Okay, anyway, I'm going to pick the one that I did this morning. And basically, this is I did the same demo this morning. And what I did, I got the same files. You can see that it's implemented. Basically, I have the front end, the new page. It's now implemented according to what we saw. And if I try to run this, let's see if we can actually have this new functionality and this new page. That would have taken me hours to implement myself. Let me see if we can get it running in just these 4 minutes that we had. Front end, are you alive? Refresh. Yeah, and there we go. So that was me implementing this new page in a matter of minutes that would have taken me hours without GitHub Copilot. And that's what I wanted to show. Thank you.
Wow, that was amazing. What would be a demo without some good demo effects? Thank you, Jonas, for showing us how GitHub Copilot can help us code with confidence and ease. And I'm sure you have a lot of questions for Jonas and the other speakers, so feel free to use our chat Q&A section. Next up, we have Adrian Knapen, Senior DevOps Consultant at Efficode, who will share their experience from onboarding GitHub Copilot in practice. Please welcome Adrian.
Hello. Welcome to my talk, Experiences from Onboarding GitHub Copilot. I'll be talking on how to embed GitHub Copilot into your organization. As announced, I'm Adrian Knapen, a Senior DevOps Consultant at Efficode. And at Efficode, we're roughly 600 professionals leading DevOps developments in Europe for our customers. We're a strong partner with Microsoft and GitHub. And based on these experiences from having customers who want to use GitHub Copilot and who want to get it into their organization, I will be telling you how you get this done. But a step back. So tools are mankind's edge. Here we see an illustration from DALL-E. Well, it's one of the tools, at least I sometimes try to use. Don't think it is this useful to kind of show our process as humans to become better at making tools. But it's quite evident. Here we see a graph which shows the energy expenditure it takes different species of animals to move around. And we see that humans are somewhere in the middle, if you can find it there. And we also can compare this to how tools made by humans to propel ourselves fare. And we go from, well, okay, but not that good. It's a logarithmic scale, by the way, to really good if you kind of use the right tools for the job. The sky is the limit as a human when you have the right tools in your toolbox. But it's important that you have those tools ready to go do what you're supposed to do and to build bigger things together. The same goes for when you try to build things in software development. We need those tools to be able to excel. We need those tools to build better software for our end users, for our stakeholders. We have tools to collaborate. For example, version control, CI, and project management are tools probably every organization nowadays uses to stay competitive in doing software development effectively. We have software to create software. IDEs, terminals, and application frameworks helps us to be more productive. If you would be writing code from scratch, God forbid, a compiler, every time we start a new project, we would not be really getting anywhere. And we have a code to test and run software. Testing frameworks, cloud, and infrastructure as code will probably be part of nearly every organization to actually help them deliver value. But adopting new tools is actually surprisingly challenging. We see this happen in mostly larger organizations where it just really like a lot of barriers for them to go anywhere. Buying a tool is not sufficient to have it embedded in your organization. Or if it's open source, like you have access from it like by default, but it doesn't mean it's actually used. You don't want to know how many customers we have who come to us and they're like, how do I integrate this testing framework in my stack? We've never done unit testing. They have access to the tools, but they're just not using it. So there are a couple of common barriers we see which prevent actual adoption of these tools. The most important of this is lack of awareness. You might have a tool at your disposal within the organization, but you're not aware that it exists. There is no internal knowledge sharing that this tool is available for you to use. You cannot find the information. No one is talking about it. We have friction to onboard. So maybe you now know that the tool exists, but getting access, getting that license assigned requires a ticket to IT, which then takes 3 days to turn around, or you need to find the right person to add you to this one group to be authorized to start using the tool. Maybe you have insufficient knowledge. So now you get to the point that you have awareness of the tool. You know how to get onboarded. You're onboarded, but you do not have the capacity to actually use the tool effectively. Security and compliance obstacles. Again, larger organizations often see this as that the tool is whitelisted for some part of the organization, but not for all. Also, Gen AI is one of these tools where, because it's so new, it's really unclear where you can use it and where you cannot use it. And maybe because your project uses personally identifiable information, you just cannot use the tool or you're not sure about this. And unproven benefits. And this often slips the mind of most engineers who have these tools available to them, but they might not actually believe in them. Again, this unit testing framework, like I've spoken to plenty of customers who are like, well, I don't know about this unit testing thing. Like, does it actually work? It does, by the way. So yeah, embedding a tool in an organization requires significant planning and effort. And be ready for that. And Copilot is such an awesome tool, and I would recommend every developer to have it in their toolbox. We have already seen talks where it shows the power, and we'll have many more talks about it, which shows you the actual power of Copilot. But things like the productivity, developer experience improvements, and code quality are not to be missed. So that's why I'm talking here about the path to successful adoption of Copilot. And to make it simple, there's 3 main pillars we'll be covering today, which you can take into use to roll out Copilot and embed it in your organization. Just using it is not enough. It needs to be part of your organization, and you need to use it also going forward. The first is the obvious one. You need to start putting Copilot in the hands of your end users. This is the first step from adopting Copilot. It's your 0 to 1. Going from no one using it to your entire organization having access. It's the logistics. Then it's encouraging effective use. You want to build a culture of continuous learning inside your organization. Copilot is a vastly changing technology. I was here last year presenting it, and then it was just an autocomplete on steroids. It was powerful, but now we've seen all these cool new features like chat, pull request aid, all these things, and will also only expand from here on out. For that, you need to have this culture in place, where people share the best practices, also specific to your domain. And lastly, measuring success. Prove the value Copilot is adding to your organization, to your stakeholders. This will both be management who is paying for it, and the end users using it on the ground, like the developers who use it every day. So, first of all, how do you get towards putting Copilot in the hands of your end users? There's the preparational paperwork, I just called it. It's all the things you need to get ready before you can actually start using it. It's security and privacy. You probably have a team for that. Legal and IP questions, and license sourcing. I think the first 2 here are, there will be existing processes. However, with Gen AI in the mix, you probably need to have a policy for that. We see that a lot of organizations, when Gen AI started to emerge, had really restrictive policies. They came to us, we would like to use this. However, we do not actually know how to take this into use securely. I would recommend everyone, all organizations, to at least have the way to experiment with it in a safe environment, and then spread from there. There are always risks with new technologies, but this is a really big one, or opportunity missed if you do not jump on this bandwagon. Then license distribution. Again, like larger organizations will see this as more friction. They will not have the capacity to roll out their licenses globally through the entire organization, or they will not have the capacity to actually help their end users when they are getting used to this tool. Our typical way to do this, or at least what has proven most fruitful, is that you want to find early adopters who are advocates for this. You want to use their experiences and their willingness to innovate to actually help the rest of the organization adopt this. Everyone is busy all the time. They will need to have some excitement, some golden path for them available, which is specific to them and can help them excel. In the smallest group you start with, you find just individual adopters, someone you would talk with in the hallway who would be excited about Copilot, who knows a lot about the organization and can help you get that adopted. Get a couple together, let them use it for a while, do some piloting, get them used to it. And then you start with advocating teams. So again, you want to have teams who have this excitement about using the tool. They have excitement about using new tools in general. They're willing to speak out about it. And you want to have them to be the champions of your push of getting Copilot rolled out. And then lastly, you expand from here with all these good experiences, with all these teams behind you who have had success stories with this new technology. You go for organizational wide rollout, where team by team you kind of roll it out throughout. So now that we get to the point where these licenses are being distributed, what's really important is you also have awareness that this is happening. That's what I started with. People need to know that a tool exists before they adopt it, obviously, otherwise you will never get anywhere. Get Copilot on the radar of the users who you will roll it out to. You can do this through a rollout plan, or at least announce to people that the licenses are coming And ideally here you can already kind of create some sign-up lists or kind of just gauge engagement, like who wants this tool before it's ready. Then when you start rolling or onboarding your users, send notifications to them with some guidelines and learning resources. I will get to that next. It's also part of continuous learning, but this bit where you kind of engage with your end users, with the one you're onboarding, that like, you're ready, we will roll you on or onboard you really soon. This is what you need to get started. With this package, you open a communication channel. And this is important later on because you get feedback from your end users. Why it's working for them, why it's not working for them. And you can do this early on because you're doing a phased rollout to get this information and actually steer the rollout and make sure that they have all they need to start using the tool. So the next pillar is encouraging effective use. So you have users actually starting to use your tool, but now you want to have them get the most out of it. On the one hand, GitHub Copilot is a really simple tool. I compare it often to Google search. It's quite intuitive to use. Like, you can find the information you need. And the same with GitHub Copilot. Like, you can easily get it to do things for you. But at the same time, it requires knowledge about the tool, how to use it. I recently went one of the trainings from GitHub on using GitHub Copilot myself after using it for well over a year. And still they found like was one new button in VS Code I wasn't aware of. There's a lot to explore. There's a lot of different ways to use GitHub Copilot. So this is definitely worth it to kind of keep investing in actually being better and more efficient at using GitHub Copilot, even after you've been using it for a while. You can always learn. So first off, go with hands-on training sessions. I say here hands-on. I think you can also do it as asynchronous learning material, but it works way better when you have it hands-on at the first. You get people started because people will start with GitHub Copilot with different knowledge levels, with different expectations. And during such a short hands-on session, I would say like roughly an hour, 30 minutes for kind of getting them to use it or kind of explaining them what it is, and 30 minutes of kind of helping everyone to start using it, you'll have everyone in your classroom be able to get their first coding suggestion. Then from there on, you can have advanced trainings, like 4 to 7 hours, I think in total should be sufficient to, you can break that up through like, let's say 2 mornings, to get deeper into Copilot, to actually find all those buttons in the UIs, explain all the new tools which are coming up, explain how to use chat, and so on and so on. This second part of this pillar is internal knowledge sharing. You want to create this continuous learning cycle. You do not just want to deliver trainings and have people in a classroom-style training. It's way more important that you foster this culture that you're building so far using Copilot, and also in a way that people share their experiences and their well-working patterns in an open forum. At Evico, what we do internally is a lot of interest groups. We have a lot of interest groups are centered around different technologies. And from there, what we see is emergence of interest to kind of give talks. For example, like brown bag seminars, they're often called. We call them knowledge sharing. It's a bit of a generic name. And also we have always regular open forum calls. So these are huddles, we're a Slack house. And there we see that every other week, we try to kind of have an hour dedicated where people with the same interests come together and they share what works. And over practice projects, you don't want to know how many customers we've seen who come to us with a demand or request to find a way to integrate Copilot into their organization, only to have an issue that they are like, but what do we use it for at the start? All our technology is so sensitive. We cannot expose it to the risks of Gen AI because we don't have a policy in place which allows it. And that's all fair and well, but they're missing out big time. I think it's not hard for most companies to just have a simple, safe, lightweight practice environment, and it will pay off later too. Like, it will always be good for you to have a practice code base, which you can just spin up and try something out. It's for the new guy joining, or in this case, for everyone who wants to try out code spaces without having any risk. Just you have a couple of pre-made exercises that will definitely help everyone to kind of just know what they can do. There's this community-maintained patterns and exercises guide. It's really good. It is about how you use Gen AI in writing code. It comes with, like I said, patterns and exercises, and it's good at kind of just having a foundation of different ways how you can use AI. For example, having kind of like a reverse test-driven development approach where you use Gen AI to write tests and then generate code, or vice versa. And then lastly, measuring success. So this is what we often forget when we adopt a new tool. We buy the new toy, we give it to everyone is happy, but we forget to actually measure how it's working. And this is really important to have as part of the plan from the get-go. Ideally, you already have key value delivery metrics in place. For example, you have DORA metrics to track your change failure rate, for example. Or you have direct business metrics. For example, at Netflix, they use the amount of concurrently watching users in their platform, also in the operations, to see how they're doing. You can try to tie any kind of change to that and measure whether there's an uptake in your actual business metrics. A proxy for this could be cycle time, just how fast you can churn out features. Features are not always kind of the same as value, but it's closer to the development, so it might be easier to measure in this case. And code quality. We have a lot of good automatic code quality analysis tools. And you can see if a team starts adopting Copilot, how does their code quality change? Can you show to the business that you're actually doing better with this tool at your disposal? So the second step is developer experience surveys. It might sound a bit fuzzy, especially to a lot of engineers. It's a lot of self-reported experiences from Copilot, but I think this is really powerful because developers are a great asset to your company. It's not just that we write software, which makes the product, which makes the money. It's that we are there to have a lot of experience in our heads, which is implicit, which we take to the office every day. As such, churn is really expensive for an organization. So just having a more enjoyable way to work. If I can get Copilot to write all the boring boilerplate for me, that's already worth it. I don't even need to be more productive if I just enjoy my work more. It will make you more productive, but just to this is why this part is so important. You can prove that your people are more happy. Focus on things like flow and cognitive space when you have these surveys. Are you able to work continuously? Do you not have to look up for things? Can it simplify the code base in a way that is easier for you to understand and therefore better for you to work with? What is the satisfaction of working with the code base? Are you frustrated with finding information or learning? And again, one of the under highlighted use cases of Copilot is the ability of Copilot to teach you about things you're working with. Let's say you start learning a new programming language. It's so easy for it to give you suggestions on what you would be valid, and thus for you to learn without having to go to the manual every time. Don't be afraid to ask things, and this is what you can ask also in this developer's experience survey to just figure out are people actually able to learn from it. If they say no here, by the way, go back with your continuous learning path and make sure that you have content for your end users on how to use Copilot for learning. And then lastly, we have the Copilot Metrics API. It's in beta, it's really new. So I'm presenting it here, but you can use it already, but it's beta, so a bit of remark there. It allows you to directly see how much usage you have been from GitHub Copilot in your organization. Things like the acceptance rate, how many suggestions have been given on a certain day, how many of them have been accepted, and how many lines have been accepted. You can see the same for GitHub Copilot chat and group by language. There will be support also for grouping it by teams. It's recently scrapped for them because it's in beta, but it will come again, hopefully. And to view the data in the GitHub from this GitHub Copilot Metrics API, there is this really great open source tool, and it just allows you to have a static website to render this information. It's still a bit of a technical you need to be quite technical to run this, of course, but luckily we're here with developers, so I'm sure you guys can manage. And what you will, for example, see is these graphs with acceptance rate, or grouping by languages, or having total active users. And this is a tool which has been requested so much by our customers, because they need to prove that this tool is actually used. And because Copilot runs for a large extent on the end user device, it's hard to see the impact for our business side. How to show to your manager that code comes from Copilot. Maybe now with the pull request feature, it might be a bit more clear, but at the end of the day, you just check in code, and whether it comes from Copilot or not, it's hard for them to prove, and therefore it's hard for them to also justify the business purchase decision. So this is a good tool to convince everyone that what you're doing is actually used every day. You can see it from the last 28 days, day-by-day metrics, and just get a good view on that it's actually a tool which is being used. So in conclusion, embedding new tools in your organization requires planning. We see this with all the types of tools our end users integrate, and Copilot is no different. Luckily, it's quite an intuitive tool to get started with. The 3 pillars to focus on when you start implementing GitHub Copilot in your organization is, first, have a plan on how to get it in the hands of your end users. Then build a community to encourage effective use. And lastly, focus on measuring and celebrating the success of adopting Copilot in your organization. Good. Good luck with integrating Copilot in your organization. I'm Adrian. Connect with me on LinkedIn and have a good rest of the talks.
Thank you, Adrian, for sharing your insights and tips on how organizations can be successful in their GitHub Copilot onboarding journey and adoption journey. Next, we have another expert who will give us some practical tips on how to use GitHub Copilot effectively. Let's welcome Saya Sarinpa, a passionate code whisperer at Vincit. She has over 15 years of experience in software development and design, and she's passionate about creating user-friendly and accessible solutions with modern technologies. She's also an active member of the developer community, a fellow Women in Tech ambassador, and a frequent speaker at events and meetups. Saya is going to walk you through her history with GitHub Copilot, sharing a quick overview of the features and how she has found them useful in her work and leisure.
Hello, everyone. I'm going to share you about how I found GitHub Copilot as a tool that I can't live without anymore. There's not going to be any secrets in this presentation that you couldn't already found from the numerous blog posts about that have been written on the subject already. But it's more about my personal experience about the subject. And next, I'm going to show you answers to a few questions. First, who am I? And how did I end up using Copilot? And in which tools I have the privilege of using it? I'm a developer, designer, and a staff expert of IoT in the embedded community at Vincit. Vincit develops solutions for customers that allow them to take full potential of AI, but also they take care that the employees can use the best tools available. So that's why I'm here today. I've worked with a wide range of technologies, started with mobile Linux, with Qt C++. Then I studied how to develop for iOS, first with Objective-C and later with Swift. And then I dived into the world of web. I first learned to do some Node. Then I later learned to code with React. And lately I've been learning Next.js. So how about the GitHub Copilot and how it relates to my journey? Less than 1.5 years ago, I got the opportunity to get the business license for the GitHub Copilot. At the moment, it had only the code completion feature, but I was very excited about it and wanted to be among the forerunners of the persons who got to utilize the AI tools in their daily work. And who could refuse of something that could assist in your work to do the most boring tasks? Like Adrian said it really well, that you don't even need to be very productive, but if you enjoy your work more, it's already worth it. And less than a year ago, the Copilot business accounts got the privilege to try on the Copilot beta chat. And I was very amazed by it. I use it every day, and I rarely exit my editor anymore to go to the traditional ChatGPT to ask any questions, because everything I need is already inside the IDE. Of course, I still use ChatGPT on my personal life, but that's a different story. I use Copilot in Visual Studio Code. that supports the full feature set of the Copilot. I also use it in Qt Creator, but unfortunately, so far, it only supports the code completion features. But I hope in the future we will see the chat as well. And if you're not a hero coder, if you ever need to, well, search anything from Stack Overflow or anywhere else from the internet, you're probably not a fan of AI assistant as well. But I'm not one of those. I will shamelessly leverage everything I can get in my hands. And of course, I know the caveats that no code, it doesn't matter who has developed it, shouldn't be pushed to production without a proper review. And of course, I need to be very careful when I'm developing something around cybersecurity. Next, I'm going to give a few examples of in which kind of different projects I've been finding Copilot very helpful. The first is the project where I used a completely new language for me. The second one is a project where I used a language that I hadn't been using for a long time. And the third one, I used familiar language, but I needed to produce code very quickly. And the new language case, that was actually last December. I participated in the Advent of Code challenge, where you have one challenge to solve each day of December. And well, you might think that it's not very wise to use any AI assistant in that kind of projects, but oh well, I wasn't taking it that seriously. And I also only used the code completion features and solved the actual problems myself. I decided to learn Python in that project. I hadn't used Python before for anything else than editing other people's code. So that was very new to me, and Copilot was very helpful to complete the API. So I learned the syntax, and that project went very well. The second case I have here is one where I used 3 technologies. There was Qt, React, and Three.js. They were pretty familiar all to me, but Three.js I hadn't been using in like previous 10 years or so I needed a refresher. It was very helpful for me to use Copilot to help me with the library I found. There was this React tree fiber that offers bindings to Three.js for React. And the third case was with a familiar language. I had recently learned Next.js that, well, I could say I could write it very well, but I knew that I couldn't complete an app in a day. I was using it in a company hackathon. And with the help of Copilot, I just shamelessly used the chat and create the architecture of the project myself, and just asked chat from like whatever I need to complete any file of my project, and just paste the results into my code. And I managed to create an app in a few hours, and I also baked a pizza in between. So that's totally possible. Here are some more use cases for Copilot. It can help you create mock data, generate tests, changing format, for example, from XML to JSON, or changing code snippet to use a totally different language, creating better comments on your code, or even documenting your whole code base, or creating translations from language to another. It can also help you with regular expressions if you don't remember all of them by heart, and also help with general purpose code snippets like validators and such. And of course, it's a big help for remembering stuff, well, you don't actually need to remember any APIs. It will complete them for you. I'm not going to go any details with these ones, but they might pop up later when I'm going more thoroughly to features of the Copilot and how I've found them useful in my work. So now let's deep dive into these 3 features. There's code completion, inline chat, and Copilot chat panel, and how I use them. If I mention any shortcuts or context menu options, they can be applied into Visual Studio Code. So everything started with the code completion. It helps to remember the language syntax, and it completes it for you. No need to write any boilerplate anymore. If you are familiar with the language, the Copilot does everything for you. And it's more than your basic IDE auto-completion, because it knows the context of your active file. It suggests some code while you're typing, and it can suggest how to write the rest of the line, or it can create whole code blocks. And it can give multiple suggestions, and you can select between them, accept any of them, or discard all of them. And you can do also a little bit modest prompting by writing a comment. You could, for example, write a comment like, initialize variable foo to 0, and it will write code for you, like const foo equals 0. But that's a little bit a bad example, because it would have been probably faster to write the code yourself. But you get the idea what can be done. The chat, it came later, but it was a very welcomed addition. It has 2 ways to operate, either inline, in the editor where your code is, or as a separate side panel. And the inline chat works a little bit like comment prompting, but instead that you write the comment itself to the code, you write your prompt straight into the chat. And also the chat has bigger capabilities. It can add, modify, or remove code. It always makes the suggestions and doesn't modify anything without your permission, so you always need to accept the solution first. If you don't need all the code that is included in the suggestion, but want to use maybe part of it, there's a handy option. It's behind the discard button. There's this arrow, and you can select there, discard to new file. Then you can pick any code from the new file you want and attach to your own original file and keep the rest of the code intact. Also, the inline chat can be opened using shortcut Ctrl+I. The chat panel, it's a little bit more complex. It allows discussion. You can iterate the results, and you can continue the discussion by yourself, or you could use some ready-made suggestion by the chat panel for the continuation of the discussion. It's very handy to use for something like you could ask if some feature is possible to develop or how to create a feature, and then you can code it by yourself if you want. Or you could take the suggestion and copy-paste into your code, like I did in the hackathon. So the scope of the chat panel is your active file in the editor, but it can be expanded with chat participants or chat variables, and I will be talking about them next. And always, if you need help with specific part of code, you can just copy-paste the code into the chat panel, and you can get answers, whatever you want to need about that code. The chat panel can be opened by pressing Ctrl+Alt+I. Okay, so the chat participants and chat variables. They are specific to the chat panel. There are multiple chat participants available, and they are referred with the @ symbol. So if you type @ symbol to the chat panel, the chat will suggest all the available chat participants, and you can select between them which one to talk to. And the most useful I've found of them is the workspace. So you can address it by saying, for example, at workspace, how many files do I have in my project? Otherwise, the chat panel does not know anything about from your chat app infrastructure, so this workspace will expand its scope to know about your current code base. And there are also a couple of more available chat participants. At least there's VS Code. You can ask VS Code of, for example, if you are want to install some extension or create a plugin for VS Code. So that will be very helpful in it. And also there's a terminal, which you can use for terminal-related questions. And it can help you, for example, for installing NPM packages. Chat variables. They are something that can define the scope for the code that you should be analyzed. There are a couple of variables available, and they are referenced with a hashtag symbol. One of them is a file. You could say, for example, at workspace, hashtag file, :index.tsx, what is inside this file. And it will tell you what's inside that file, even though you don't need to open that file by yourself. So the variables are very helpful in that sense. Another useful one is editor, hashtag editor. You may think how it differs from the basic scope of the chat, if the chat already knows what you have open in your editor. But normally, the chat only knows either your selection or the whole file, but not both at the same time. And the editor allows you to give both of those scopes at the same time. And you could do queries like hashtag editor, I have this code selected, can I move it between lines 6 and 7? And because it knows the context of your selected code and the whole file, it can say if it's safe to move the code between lines 6 and 7. So there are also some ready-made commands. There are more of these, but I will be talking about those ones that I used most often. So explain, fix, doc, and tests. Explain. It explains the code. It's quite self-explanatory. You can either select part of the code to be explained, or you could give it to explain the whole file without making a selection. There's 3 ways to access these commands. You can either pick from the context menu, Copilot, explain this, or then you can write it in the inline chat or into the chat panel. And in any case, the answer will appear into the chat panel. Fix command, it's also something that I use very much. It can help you fix typos, and if you're omitted a variable introduction or something like that. And that is better used either in the inline chat or from the context menu, Copilot fix this. And there's also another way how to use the fix command. I, for example, used it for adding TypeScript types for code that doesn't have them yet. And that works better from the chat panel. It analyzes your whole file, and if your file type is .ts or tsx, and the IDE knows that the missing types are problems, then you can fix them by using the Copilot chat. The doc command, it's very handy. It creates JS doc style annotations, and you can generate the whole code documentation out of that. It's used similarly. You can use it either from the inline chat, context menu, generate docs, or from the chat panel. And also the tests. It can create unit tests for your code. You can either select some piece of code to test, or you can let it create tests for a whole file. And it creates you a separate test file. Of course, you can use that command also from the chat panel, but it's not that helpful because you need to copy-paste the contents from the chat to your separate test file. But from the inline chat and from the context menu, generate tests will provide the file by itself. And by default, it tries to deduce from the code that which testing framework would be the most suitable for that code. But if you don't like to use the default one, then you can advise, for example, say /tests unit test using Playwright. And it will create a test using Playwright framework. And that's actually all this time. If you want to connect, I'm on LinkedIn. I hope you liked the presentation. Thank you.
Thank you, Saija. That was an awesome session with real life examples. I learned a lot from that. Next up, we have our own Juha Karvonen, who's Senior Cloud Solution Architect at Microsoft. He will tell us more about Azure AI, which is a comprehensive solution and a set of AI services and tools that enable you to build intelligent solutions across the cloud. He has over 20 years of experience in software development and architecture, and he's passionate about exploring new technologies and solving complex problems to benefit his customers and partners. Juha, the stage is yours.
Welcome developers to the DevX AI event. Next we are talking a little about AI, Azure AI, and how it can help developers in their daily work, not just building chatbot using Azure OpenAI services. I've been quite long in the software industry, and I would dare to say that this is the most exciting time to be a developer. And of course, AI has something to do, or quite a lot to do with that one. If we take a look about, compare the, for example, ChatGPT that was released to the other previously well-known technologies, that how it was adopted by the users. For example, mobile phones and internet and Facebook, nice curves that slowly were rising up. But with ChatGPT, it's vertical line. It was only 2 months to adapt 100 million users for that one. For Facebook, it took 4.5 years for the same amount. One thing, there are a few things, of course, that has effect on this one, and one is that we finally had an interface, easy interface that we can communicate with the AI. AI is old stuff, it has been lived here for a long time, but now we had a natural language that we could use to communicate with the AI, ask questions, get answers. So it's easy for everyone to use. The other thing is the size of the AI models. If we take a look, for example, go 6 years back, the largest machine AI model had 345 million machine learning parameters. Only 2 years after that, GPT-3 had 175 billion machine learning parameters. Before it was released last year, it had 1.7 trillion machine learning parameters. We all know what million, billion, and trillion is, but to set some context with that one, if an ordinary human being like you would start to count from 0 to 1 million, it would take approximately 11 or 12 days to do that. So what about billion? 1,000 times more. Can't be that much longer. Well, in fact, if you start to count to 1 billion, it would take you 32 years to accomplish that one. And of course, the trillions, 1,000 times more, 32,000 years. I just imagine that how long it would take to write a software with meaningful if-else statements. 1 trillion if-else statements. I do not even know. But this is maybe the most crucial thing that I think every developer should start using AI. We have all this power in our hands, and we don't have to write only a few lines of code, and we get this amount of knowledge and power inside our software. But we all know that when you are developing software, building a software, running a software company, it's not an easy thing to do. We have challenges everywhere. Our main focus is to keep our customers satisfied. We need to deliver new features all the time. We need to get new customers in. And I wouldn't be surprised if you now and then have 1 or 2 bugs in your program that you need to fix. Almost all the time you spend goes to testing, keeping your customers satisfied, fixing the bugs. And then we have technology. New technologies coming all the time. Not only AI, but new frameworks, everything that you need to implement your solution. And the technical depth just grows and grows and grows. I need to modernize this software, and you need to modernize that software. And at the same time, it's not easy task to find skilled and talented people to hire. Yet alone, keep the existing ones in the company, keep them happy, and make them more productive. Luckily, this is where AI comes in the picture, and it's not the one problem more you need to solve, but it is a solution for these problems. There are 2 ways to approach this one, that how AI can be implemented in the software companies. The first thing is that you can boost your developer experience with that one, enhance the developers' daily work, what they are doing. And the other thing is that you can implement it inside your application, making your applications more intelligent. And the solution or approach for these both ones are simple. Just use the next slide, please. Choose and use the tools that you have. Simple as that one. And this is great because we have a lot of tools. But let's start with the DevX first. And what I mean with the developer experience, it's the tools, the systems, the technology, the environment, the culture that you have inside your company. And the study says that when you make the developer experience better, you will get your business more better, because you can get faster time to revenue. Think about it. When your developers are more productive and they can deliver software faster, you will get revenue faster. And it will also improve the operational efficiency because people are more productive, they are more efficient, and the product quality will also rise. And when you have all the tools in place, the culture is good, and everything is working, of course, it will raise the team morale, and it's easier to keep the existing developers in the company and also hire new ones. And McKinsey study says that AI has a pivotal role with improving the developer experience. It says that when AI is used, it's twice as likely to report overall happiness, fulfillment, and state of flow for the developer's work. And this is where the GitHub Copilot comes in the picture. We have seen many great speaks about GitHub Copilot, so I won't go deep into that one. I just want to mention that its ultimate goal is to maximize developer happiness, increase developer productivity, and accelerate software development. Quite bold words, but so are the studies made about GitHub Copilot. Microsoft and GitHub has made a lot of studies that how it really had improved the software productivity and happiness. But I will show you one study made by Accenture. They did a 6-month study when 450 of their developers started to use the GitHub Copilot, that what impact it had. These numbers are even better than the studies that we have made. 94% say that they can stay more in the flow because they don't have to go to the internet. They don't have to go to the Stack Overflow finding things. They can stay in their development environment, ask questions, and get answers back. And that will also result for the 90% saying that they need to spend less time looking for the information. 90% says that they can write better code after GitHub Copilot. Maybe the most interesting number for me is in the bottom right corner. 90% say that they are more fulfilled for their job. They are more fulfilled what they are doing. And this is because they can leave all the boring stuff for the AI. They can focus planning, ideating, doing the real coding, and just let the AI do the unit test and write the comments or find the bugs. So this is quite incredible tool. Another tool I want to mention, even though it's not a developer tool as is the Copilot for Microsoft 365. Because if you can enhance, maybe you are a developer that don't ever need to write any documents or use any office tools and participate in any meetings, but I doubt that one. So if you can accelerate your daily work using the AI in office tools, just do that. Let the AI do the meeting minutes from the meetings, or write the document, or create your PowerPoint slides, or summarize your emails, and that stuff. So that is one thing with the Microsoft Copilot, that it will enhance your daily work. But start using these also because they will give you a perspective that how we have implemented the AI in our solution. And it will also teach you how to communicate with the AI. Because when you are starting to build your own solution, it will give you ideas and you know how to use it. So start using that one also. So that was the developer experience, the daily work, how you can enhance that one. And then the next thing is how to make the apps more intelligent. So it can be just you create a chatbot or put the AI in your solution, but this is more like a paradigm shift that you need to think that how things are changing from the current applications to more intelligent applications. Because in current applications, we usually have constrained interactions, meaning that we have a button there and combo box there and something you need to check there, and then the user will get some results. But when we move from that to the natural language interaction, the software can do so much more. It's not pre-said that by clicking this button you will get this answer. You can talk it with the natural language. And it's from moving from the hard code and fixed data sets to the data-driven development, where data is more broad subset than just a SQL database. It's the whole data that your company has or your customer's company have, and add it with some additional information from all around the world. And it doesn't mean that it's more hard to do. It should be, when changes in the current software is cost and complex, it should be more easier to do. Because think about it, when you implement AI in your solution, you are using that one, and the model comes more intelligent and intelligent, your software also comes more intelligent without you having to write any new code. And once again, here the Microsoft comes in the picture and the Azure AI. We have a huge set of AI services here. We can see that there's this box Azure OpenAI service, which is really, really great, but it's only one part of these services. We have pre-made models built as a service. You can do video indexing, you can do image recognition, facial recognition. We have these pre-built services. And then on top of the Azure OpenAI service, we have the model catalog. There are over 1,600 AI models from other providers. And if that's not enough, we have the Azure Machine Learning that you can build your own models, train those, and run those. So we have many services. How to tackle that, how you should start building on this one. There are a few approaches that you can think about, that what AI solution, what AI technology you should use. Should you use the services I mentioned? We have already made the video indexing, finding object in the picture, or translation or speed recognition. Or do you need AI models? Do you want to use OpenAI models? Do you want to use Llama models or something else? Or do you want to create a plugin for the existing Copilot that we have created? Not using AI in your solution, but maybe using your solution and business intelligence in the AI. Other thing to consider is the size of the models. Of course, everyone wants to use the newest and biggest models, but maybe that's not appropriate every time. Maybe you need a model that needs to run in small computer, on the edge. Then you can find some of the Azure AI services that you can run in the container. You can put in a container and on-premise environment or in the edge and run it there. Or maybe you need to optimize the price of these models. You want to use small language models. So there are a lot of options. Maybe start with the biggest one and the fanciest one, and then find out what you really need and downsize and find the right model you want to use. And also how you want to deploy these models. Do you want to use model as a service and pay as you go? The model is running somewhere else and you just pay for the tokens and that's it. You don't have to worry about that one. Or do you want to use model as a platform where we build up the infrastructure for you? The model is running inside the VM. You have some control over that one and you are paying for the compute. Or do you want to build your models by yourself using Azure Machine Learning from the ground up, set up the virtual machines and virtual network infrastructure? So there are a lot of choices to choose from. And once again, there are a lot of choices, but we have made this easy because we have only one access point for the developers currently, Azure AI Studio. And in this slide, it says that it's in public preview. We can put a cross over that one because 2 days ago in the build, it was a release that it's now generally available. So it's for everyone to use. Let's take a quick look about how the Azure AI Studio looks at the moment. So all you need to do is go to this address here, ai.azure.com. There you have access to all of this and a lot more. And if we take a look, for example, start screen, here we can find that we have the AI services. Okay, sorry, my screen wasn't showing up. Let me do something here. Yes. Sorry for that one. Let me show it again. So we have the address is azureai.azure.com. Only address you need to know to go to the Azure AI Studio. And here we can see that we can find out the AI services I mentioned. Oops. AI services I mentioned are here. And we have the model catalog here. And we have also the Azure OpenAI. So if we take a look, for example, the Azure AI services, here we can see services for the speech, language, translate, vision, document, and content safety. And if we take a look about the model catalog, currently there are 1,667 different kind of models. And if we try to, we can filter it by the publisher, if it's Microsoft, if it's Meta, and for the purposes. But if we click here for the deployment options, we can see that, let me zoom in. We have the choice for a model as a service. We can run that, get just an API and run that somewhere and pay for the consumption. And we have the model as a platform option also here, and we can filter those options through that one. And if you are, for example, unsure about what is the speed and how fast these models are, we have also the model benchmark here. You can compare all of them or click some of those models, and we have run common data sets. You can use your own data also, but we have run common data sets against those models, and you can just compare up that how they have accomplished the tasks. So there are a lot of here. And for developers, the most important and interesting thing is that all that you do here, no matter what how you publish the model, you can play around it with, you have a playground, and you always get the code and also the API endpoint that you can use to call that model. So, let me finalize this one. What I wanted to deliver you. Let me click that one. That key takeaways, use AI in your daily work. Use GitHub Copilot, use M365 Copilot, explore the ai.azure.com, and then choose your approach. Play around and choose what you are wanting to use. That's all from my side. Thank you, and enjoy the rest of the event.
Thank you, Juha, for that enlightening session. I'm sure you all gained a lot of knowledge and inspiration from his overview of Azure AI and its capabilities. Next, we have a case study that will show us how a real-world organization is using generative AI to create value and impact. Please welcome Tuomas Lahtinen from Loihde, who will tell us about their project AinoAid, a conversational AI platform that helps elderly people with loneliness and well-being. Tuomas is a business development director at Loihde, a digital service company that provides solutions for health and social care, education, and public administration. He has over 10 years of experience in business development and digital transformation. And he's passionate about creating human-centric and impactful services with AI. Tuomas was to present today with his colleague Joonas Järvinen, who unfortunately could not make it today. But over to you, Tuomas.
Thank you, and I'm happy to be here presenting on this topic. The background for this talk is this thing we have created as a partner with our customer, vEncourage. So we have created something called InoAid, and it's a solution that uses generative AI. So I'm going to go into that and perhaps share some useful experiences also for other developers and creators. So first of all, the problem that has been approached by our customer for a longer time has been how to offer help for people who have difficulties with their close relationships, in particular domestic violence. And that's a topic that has a very big global impact, and it's severely under-resourced. So for us as a technology house, and for me personally, this presents an opportunity and a challenge. Could we harness AI to do something good that would otherwise be not done at all? So InoAid is a service on the web, inoaid.fi, and you can test it out yourselves. And it provides information and guidance to people seeking help. And as part of this website and this overall solution, we have this InoAid bot, which utilizes LLMs, utilizes generative AI. And next, I'm going to go a little bit deeper on that. Starting with architecture, which would have been the strong suit of my colleague Jonas, but going on an overall level, some facts about this architecture. So our solution is built in Azure, apart from CMS, REST API, and Content Lake. There's a bot client at the website which talks with chatbot through Azure bot interface. And when there are changes into the content management system, new material, those knowledge are brought in using a webhook to make sure the bot and the vector database always have the most up-to-date information. And this solution bot is monitored using telemetry with application insights, and we create analytics from that data by combining it with chat history data to continuously improve the solution. And we have been the only technology partner here for vEncourage, with also assistance from Microsoft Fast Track. And then going into how the chatbot actually works. So here we have a schematic diagram of how it works. If we begin from the lower corner from the user, so basically the user comes in, sends a message to the bot. Okay, now we can be in a situation where there's a short piece of conversation history already between the user and the bot. But anyways, the user sends a message. What we do then at the tech side is that we first get the previous messages from this conversation. Then we clean identified personal information and classify the user message using that message and its history. We do different kind of classifications where perhaps most important is that we try to analyze if there's a particularly risky situation going on. Then we send this information to LLM, which optimizes the message for vector search. So we optimize so-called search query. And then we send the query to knowledge base, from where we retrieve the context for generating the response to the user. We take this context, we take the classification information, and then we put all of this into prompt. And then the GPT generates the response that we send to the user. And in those situations which are classified as risky, we don't only use the message generated by the AI, but we also include a fixed pre-written contact information card to make sure that the user has right in front of him or her information where to get fast help. And this data is then again stored into history database for monitoring and improving this solution, and possibly to be used further in the same conversation. So in this way, we have built a process flow on how the system generates the responses to the user. And I couldn't emphasize more that one of the most important factors is the knowledge base which is created by the customer and all the domain and substance expertise. I will come to that again a little bit later. Going into this kind of project, we at Loihde and our customer has seen it very important that we would try to do it in responsible and secure way. And at Loihde, we have something called Responsible and Secure AI Framework, which we have adjusted and utilized in this situation. So you can see it here. We have drawn it in the format of Responsible and Secure AI House. So first of all, there needs to be value and impact. There needs to be some need, something useful that we are aiming to do. So we definitely address a significant problem in an area that has global significance, that lacks resources. So that's good. It's something that might be left undone if not with some technology like this. Then we have created AI governance principles for this solution, drawing from our experience with AI governance and in discussions with the customer. What are the principles of AI governance for this solution? And we have created an operative model how those principles are made real, and how there is also continuous development, which means that we have technical, we have procedural, and we have also human training related measures in place to ensure the governed use. Green AI is something that we refer to as aiming to do good things in perspective of the green transition, but also being aware of the energy consumption of AI, and of course water is also something that's relevant. And how we do this, we try to minimize the excess uses of large models or too much compute. And well, it's quite natural to start with a very general solution, and then as we learn more and gather more data, we can replace some parts with less expensive ones. So that's a gradual development path. Then in the human-machine interaction front, things we have done are user path designs. We have drawn them out already, first ideas before we started the project. And as always, the definitions, they get better and better during the project. We have done many things to optimize the process that generates the messages to the users, as I described the overview of the workflow in the previous slide. We have done quite a bit of prompt engineering, adjusting tone of voice, trying to do all sorts of things that we found out in different testing versions that need to be tweaked. And now we are looking to optimizing how the prompt continuous development is done, and there are again new questions, and that already goes to the area of MLOps. But one more thing in the human-machine interaction design is user instructions, because as we all have heard many times, management of expectations is very critical for success. And in this kind of new area of generative AI, definitely there are many different sorts of expectations. So managing those expectations proactively, I think, is a key step. In the MLOps side, we have DevOps practices in place. We do performance monitoring, continuous improvement, and gradually increase the amount of automations. Currently, we are dealing with prompt engineering related automations. Then in the data governance area of the framework, we have the content management system, which has been specifically selected as suitable to this case, and how it's accessed and how it's structured and all that. Then in the security and privacy kind of cornerstone, we have of course, from the start, been aware of the security principles, taken those into account in the design. We have had third-party penetration tests, and we have had the Loihde cybersecurity team doing auditing and audit reports from this solution. And even if it was Loihde internal team, they didn't let us go through easily, and that's also a area of infinite possibility to improve. And finally, we are privacy aware, very privacy aware, and do not store any privacy information, and done measures to limit all risk and prevent risk in that area as well. Okay, to wrap up my talk, next, I have a couple of takeaways, lessons learned, that I would like to share to fellow developers, also to customers who are thinking of utilizing generative AI as part of some solution. So first of all the basic lessons, what we know from development, at least the high-level lessons, they still hold. And one big thing is the co-creation process with the customer who pays the thing, with the actual end users, and other stakeholders who have some stake in the solution. That's very critical, and it starts from the problem definition, which usually gradually develops also as learnings happen. Then one place is the content curation and creation, the content that in this case we have in the content management system. That's where the substance matter experts have a big role to play. Then prompt engineering, obviously that's something you at least you review the results with the customer. Let's say it's tone of voice or something. And building a whole system like this, it involves many technical and process-related decisions where the customer input, end user input, where the stakeholder perspectives should be taken into account so that we create something that's desirable, and how we resolve the different trade-offs. So even if we create with the latest technology, even if it's AI, it's still very much a co-creation process. Then one challenge that I a little bit touched upon already is this end user expectations and how they understand AI. I feel like we would need like much more information on those on a broader level, and I think some research institutions should bring that information. Perhaps there are studies that I'm not aware, but generally a topic for kind of global education, global dialogue, so that the technological solutions that we use, they are understood as they are, and so that we find the best ways to utilize them. Some kind of tensions can sometimes be seen. Okay, this doesn't work like classical knowledge service where we have every possible response validated 3 times by experts, and now we generate answers. So I wouldn't say it's replacement to that. And also this is not replacement to human chat interaction or that kind of little bit lighter services, but this is a new type of service to the ecosystem, and like what we have done here with the user instructions, telling that it's AI that generates the messages, and it might not always be correct what it says. I think that's something that must be tackled head on. Like, okay, so what if it's still useful? Even if sometimes it's clumsy, sometimes it makes small mistake, hopefully never big mistake. Then it's the current reality, and then find a right place for a solution like this. So that's something to be taken very, very seriously. Then classifying the user messages that come in, we found at least in this type of application, it was very important. I was talking about the risk classification, but we have also other things. And based on how you classify the incoming user message, you can take different paths, different routes. Like you can take more structured path, or you can take more open generative path. And well, to developers, I'm not sure if I need to repeat this, test as early as possible to optimize performance, but always good to repeat the good stuff, at least in my opinion. And then something we noticed with the Azure and worked with the Microsoft team also is Azure content filter may catch some prompts. Here might be some discussion about violence and so forth, so that must be addressed. And then for the continuous operation, we found it's important to make it easy for the non-technical team to participate in modifying the solution, modifying the static content, being able to monitor the performance on their own, being able to access the conversation histories and review the results, so that there's no kind of barrier that you always have to go through technical. That's something that we've found important. And to summarize from what I started, I think it's very exciting to try to do something that would otherwise be not done at all using the latest of technologies. And this has been very exciting project and certainly a journey also in front. That's all. Thank you.
Thank you, Tuomas, for the inspiring presentation. Next up, we have our final session for the day. And we have Mikko Lehtimäki, co-founder and chief data scientist at Softlandia, presenting their conversational AI solutions that they build for various industries. He has over 15 years of experience in data science and natural language processing, And he's passionate about creating realistic and engaging AI avatars that can have a conversation using natural language with us humans. Mikko will show us how they are creating an AI avatar that is using an extremely natural language. Go ahead, Mikko.
Hello everyone, super happy to be here today talking about these very exciting topics. At Softlandia, we specialize in creating end-to-end AI solutions for our customers. And the avatar technology is often one piece of those solutions. The title of my talk is Extremely Natural Language Processing. I'll explain what that means. So natural language processing is an old field already. It basically centers around extracting meaning and content and structure from text that otherwise appears unstructured to machines. And with the latest technology, namely large language models and avatars, we can really take that to the next level by making the natural language processing more interactive and flexible. So that's what we call extremely natural language processing. I'll discuss how an avatar can be built and how LLMs really enable the latest advances in this field. So this is one of the avatars we have recently created. If the person looks familiar to you, it's probably because they were interviewed by a talk show host, Arto Nyberg, and the interview was shown on live TV. You can scan the QR code if you want to watch the episode and see how that went. Or if they look familiar, maybe it's because you've been reading the Azure AI text-to-speech avatar documentation, where you may run into this same character. So what really is an avatar? It's a digital character who we can control. Avatars are useful in two primary modes. First is what we call batch mode. So you can give the avatar a script, basically text, that it will read out to a video with sound and movement. And you can run this process in batch mode by having a script and clicking a button and coming back a few minutes later to have your video. The other mode is in real-time interactive mode. And this is where you use the avatar in a real-time conversational setting. And that's what I'm going to be focusing here today. There are a couple of important technology drivers that are making the avatar technology very interesting right now. First is, of course, the video and audio synthesis technology. We can now create very lifelike videos and very lifelike speech. Then we have the speech recognition technology, which is very important for capturing what the users want to do with the avatars. And finally, the large language models that really enable us to create these digital personas and understand what the users want to do with the avatars and creating very, very high quality responses from the avatars. So the avatar doesn't need to have a set of answers that it uses when it answers a question. It can really adapt to the conversation in the style of chatbots that we see, for example, with ChatGPT these days. And the avatars really shine in all user-facing applications. They can make your service much more approachable than engaging than, for example, a blank page where you expect the user to type in their inputs or press an intimidating microphone button and start speaking. Instead, with the avatars, you can have a lifelike person there nodding along as the user is explaining their question or request, and you can give a realistic lifelike response. It's a very, very powerful paradigm. They can completely automate or at least assist in many use cases. We have listed a couple here. For example, in customer service and support, the avatars can be the first point of contact and then leading to actual human interaction. Or in some cases, they can completely handle some requests. In education and training, they can provide assistance for, let's say, rehearsals or retrieving supportive knowledge. In entertainment and gaming, you can create digital characters, for example, virtual reality solutions. And in marketing and brand representation, you can have the avatars represent your company online, creating perhaps even like interactive events. But you really must pay attention to the quality of the avatar experience if you are going to deploy one. There's 3 primary factors that play into this. The first is, of course, the look and sound of the avatar. It has to match the use case. If you're going for ultra realistic experience, then you want the appearance on the video as well as the sound to be very lifelike. If you're aiming for a more, let's say, cartoon character, then the requirements are different. But we can achieve very high realism these days. It needs to have sufficient knowledge about the subject matter that you have deployed the avatar for. So that means that if it is a assistant for frequently asked questions, it should have the answers available to it. You need some engineering work here to make sure that the correct knowledge is available at the right time. And then finally, the interactivity of the experience needs to be spot on. This mainly comes down to the latency that it takes, the time it takes for the avatar to provide a response when the user stops speaking. In social interactions, this is about 200 milliseconds when a human starts to expect a response from their conversation partner. So aim for that. In the following, I will cover the Azure AI speech service, which can be used to create an avatar and other parts of the experience as well. This data flow right here shows all the steps that we need to take when we create a high-quality avatar experience. On the right-hand side, you see the Azure AI speech service that provides these avatars. This service itself takes a text input. It's the text that the avatar will repeat as speech, and a video will be created at the same time. So you provide a text input, and you receive a video stream that you show to the user. In addition to text, you can provide the SSML, which stands for Speech Synthesis Markup Language. With the SSML, you can control how the avatar moves and even affect the speech, like intonation and that kind of features. But this is only one piece of the puzzle. It all starts on the left-hand side in the diagram from the user's speech. This is typically done in 2 steps. So you have some sort of detection algorithm when the user starts speaking. It detects, let's say, a keyword, perhaps the name of your avatar. And when the detection triggers, it primes all the downstream services so that you can answer as quick and efficiently as possible. The second step is transcribing the user speech to text, because we need the text input for the downstream tasks. This you can do also with the Azure AI speech service, or you can even use machine learning models that run completely locally on edge devices, for example. And in the center, we have the brains of the avatar. This is the large language model layer. The transcribed speech from the user is fed to the LLM layer, which then provides the answer that the avatar will read out. But the LLM layer can do much more than just immediately give an answer. Like behind the scenes, you probably want to do some sort of knowledge retrieval. We've just seen a nice explanation of retrieval augmented generation methods, which can also be used here. You could use a managed service for providing the knowledge to the LLM, such as Softlandia's Yoko.ai, or you can build your own service using tools like Azure AI Search, for example. And you also have a choice with the language model that you want to use. Let's see these services a bit more in depth. So with the Azure AI speech, we get the actual avatar sound and video stream that we show to the user. It takes just the text input, so that this service doesn't include any text analysis in itself. There are a handful of pre-built avatars you can use, but you can also customize the look of the avatars. This is done by providing a video of an actor that you want to clone as an avatar. The video should have a few minutes of content of your actor talent reading text and making the gestures such as those you want the avatar to show on the video stream. The other part of the customization is the sound of the avatar. So you can also train that. You can provide sound samples and create a sound model to the Azure AI speech service. You can then mix and match the videos and sounds that you have to create unique avatars as you like. But remember the privacy here. You cannot just provide any video you found online and make an avatar clone from that. The video you provide for training needs to contain a statement from the actor that this video can be used for creating an AI avatar. It's good to keep in mind. And the documentation has a very extensive examples of what the video should contain. We found that the Azure AI speech has very good support for different languages. So Finnish and Swedish are very important for our customers, and we found good quality sounds here. Then we have the text analysis layer, which is the brain of the avatar that provides the text that the avatar will read out on video. Here, it's really an optimization between latency and quality of the responses. Because the users are expecting a very fast response, you cannot take too much time in processing their requests. And like said, the language model here can use several different technologies in providing the answers. You can use simple prompting to give the avatar a persona, or you can go more in depth and use retrieval augmented generation, for example, to connect the avatar to your company knowledge bases, for example, and retrieve the relevant information for the user's question. And again, Yoko.ai is one such service, and Azure AI Search is another option, but there are also plenty others to choose from. One very exciting recent development here is, of course, the opportunities that we have with multimodal models. So I've described the speech processing and the language model layer as separate steps, which is how currently the avatars have been built. But this is probably going to change in the near future. We are getting now access to models, multimodal models, that can take speech input, text input, even video input, and likewise directly output the audio that we would like the avatar to read out. Why they wouldn't output even the video soon? They probably will. So keep an eye on the development of multimodal models, because they will probably allow you to optimize the latency here again, so that you can provide a even more engaging avatar service. The GPT-4o is an example of such a model, and just a couple of days ago we saw an open source version, the Chameleon model, and these will keep popping up quite in fast pace. So yeah, this is a super exciting topic moving forward really fast. I'm very happy to be a part of it, and I hope you have a good time building avatars yourself. Thank you.
Thank you, Mikko, for that fascinating session. I'm sure you all were blown away by his demonstration of AI avatars and its capabilities. AI skills are rapidly becoming essential for the future, as they enable us to harness the power of artificial intelligence to solve complex problems, drive innovation, and create new opportunities. The Microsoft Skills for Jobs program offers an AI developer degree that equips you with the in-demand skills needed to thrive in this transformative era. With a focus on practical skills and real-world applications, you'll be equipped to tackle the challenges of tomorrow and make AI your work partner. So don't just dream about future, build it with our Skills for Jobs program.
Exactly. So that concludes our event for today. I hope you all enjoyed it as much as I did, and I want to thank our amazing speakers for delivering the content. But before we wrap up, I would like to thank our speakers and everyone included in the project once again for sharing their experience, insights, and expertise with us. And last but not least, I want to thank you, our audience, for sharing this event with us, for joining us today, participating, and asking questions in the Q&A chat. You are the reason why we do this, and we appreciate your feedback and engagement.
A big shout out also to all the folks working backstage at our event partner, Creative Technology. You've been working very hard to bring this amazing content and experience to you. If you have any questions or comments, please feel free to reach out to us via email or social media. We'd love to hear from you and keep the conversation going. You can also access the recordings and slides of the session on our YouTube channel. Once again, thank you for being a part of Developer X AI. We hope to see you again soon at our next event. Until then, stay safe, stay curious, and keep coding with AI. Have a great day ahead. Goodbye.